Okay, so let's make life very easy for ourselves, and let's choose a matrix, let's call it A, that has just one entry, which is complex. Okay, so it's just a 1 by 1 matrix like this one here. So it's a 1 by 1 matrix, just a single entry, and it's a complex number. Grand. So one thing we do know is that we've been representing our complex numbers in the traditional way like this as a plus bi, but you can also represent complex numbers in polar form. So if you're not familiar with this, don't worry, you can find quite a bit of information about this online. It's not very difficult. It's just decomposing the complex number into a radius and an angle rather than typical Cartesian coordinates. So it will be given as an expression like this. Okay, or it can also be written as r times e to the I theta. These are all equivalent ways of representing a complex number. Okay, so let's think about our 1 by 1 matrix A, and let's write it in exponential form here. And I'm going to restrict myself to the unit complex numbers. So instead of having r e to the I theta, I'm just going to be dealing with complex numbers of the form e to the I theta. So I'm assuming r is 1, hence unit complex numbers. Okay, so if we make that one restriction, then I can think about A as being a 1 by 1 matrix with a single entry e to the I theta, representing some generic complex number. Okay, so we've reduced it down to one parameter, theta. Okay, so the next thing you can think about is if I take a dagger. What is a dagger? Okay, if you remember from the last video, that means it's the conjugate transpose. Okay, well, the conjugate of e to the I theta is e to the minus I theta. And there's no use doing transpose because it's just a 1 by 1 matrix. So that's the final result. Okay, now what happens if you do A times a dagger? Well, then you're going to get e to the I theta times e to the I minus I theta, okay, which is e to the power of I theta minus I theta, which is e to the power of 0, which is 1. That must mean if a times a dagger is 1, that has to mean that a dagger is the same as the A inverse. And from the last video, you'll remember that this makes this a unitary matrix. Okay, it's a unitary matrix because the conjugate transpose is the same thing as the inverse. Okay, and also it's in this case a 1 by 1 matrix. So this is actually given the name U1. This is a symmetry group, a unitary group of 1 by 1 matrices. Okay, and this is actually at the heart of electromagnetism. This is the symmetry that describes the electromagnetic force. Okay, and we'll be discussing that in more detail in the coming videos.